Hello friends, welcome once again to Asomnofo Online Maths. This particular lesson is proudly sponsored by the National Brain of MetricEdu 2021. They are organizing a novel competition that will feature even graduates down to primary 5 and primary 6 pupils. So they reward students every Saturday by 8 p.m. to 10 p.m. with 5,000 naira every Saturday. So many students are benefiting from this platform every Saturday. So to register or to apply, just visit their website at www.metricedu.com. And this recent competition that will take place this Saturday is of 3 categories. For more information about this, look at the description in the above this video you are watching right away, so that you gain all the information you need to know. So in this video, we want to discuss the third circle theorem, which is telling us that the angles in the same segment of a circle are equal to each other. Okay, now if you want to understand this, you need to see a circle first. This is a circle. Okay, now remember, a segment is just an area in a circle that is surrounded by a chord and an arc. All right, so now let's say I have a chord here. Now you will see that these two angles here, let's say A and the angle B, are in the same segment. Look at where they are. They are in the same segment of a circle, because this chord that is here has separated. This is a segment, minor segment, while up here is a major segment. So angle A and B are in the same segment. Now look at this one again. You can have something like this. Do you know that this is still another chord? And this chord has divided this circle into two segments. There is a segment here, there is another segment here. Now, this angle here, let's say x1, and this angle here, x2, are in the same segment. But if I move this particular angle here, down here, you see that it is now facing a different segment. Okay, so let's go to the proof. Okay, now, take a look at this circle. Before I talk about this proof, you must understand that for you to say that two angles are in the same segment, from where they are starting must be from the circumference of a circle, where they are heading must be on the circumference too. Okay, now because if I draw a line here, this line here is now a chord, which shows that this angle here, let's say x1, and this angle here, x2, are in the same segment. But we want to see the proof. Now, assuming here is the center of the circle O, so what do we want to prove? To prove that x1 is equal to x2. That is what we want to prove, that this x1 is equal to x2. Now in construction, we need to make a construction. To make the construction we are going to make, let's say here is A, B, C, and D. Okay, so the construction I'm going to make is that I'm going to draw A, join A to O, and join O to D. That is the construction. So that here becomes the angle at the center. So join A to O and O to D. That is the construction I have to make here. Then having done that, you will see that from the previous theorem we have discussed that angle at center is twice angle at the circumference. Now this is the angle at center here. This angle at center is equal to 2 times angle at circumference. So I can write that angle AOD, this angle here, is equal to 2x1. Reason, angle at center is twice angle at circumference. Also, the same angle AOD is equal to x2, because this is the center and this is also the circumference. So angle AOD is equal to 2x2. The same reason as above, angle at center is equal to 2 times angle at circumference. Now, if AOD is equal to 2x1 and the AOD is also equal to 2x2, it implies that 2x1 is equal to 2x2. Or rather, I'll carry this and substitute here. So I can write that 2x1 is equal to 2x2. So that 2 can cancel 2, and if 2 cancels 2, you have that x1 is equal to x2. So this has improved that the angle at the same segment are equal, provided that, because this is a chord, this chord has separated into a segment A and a segment B. So this angle here in this circumference and in this circumference are also equal. Even if, so before we get into the problem solving, because we will have one problem here we're going to solve pertaining to this theorem, which says that the angles in the same segment of a circle are equal. Remember that this particular video and program is sponsored by the National Brain of MetricEdu 2021. Okay, they organize online quiz to help students excel, and they reward students every week by Saturday with 5,000 naira. And this weekend they are organizing another one. So for proper understanding of everything pertaining to that, see the description above this video you are watching again. Remember, you can apply through their website www.metricedu.com. Okay, so look at the problem we have here, and it says that in the diagram PQS, that is angle PQS, this angle here is 65, and angle RPS is 40, as you can see, and QSR is 20 degrees. Find PSQ. So look at the angle they want us to find here, angle PSQ. PS and the Q, so this is the angle we are looking for. Okay, but if you remember and understood the theorem I taught you recently, angle in the same segment are equal, you'll be able to answer this. Now, this is a chord, okay? So every angle, this is another chord, mind you. So the angle here and the angle here are the same thing. That is angle in the same segment. Look at it, 20 and here are the same thing. So this QPR, I can write QPR is equal to 20 degrees, reason angle in the same segment. Angle in the same segment, as you can see, QPR, this angle here and this angle here are equal. So here is now 20 degrees. Now let us consider this triangle PQS. Look at how the triangle looks like. Triangle Q, P, and S. Remember, here is now 20 plus 40, this angle here, and 20 plus 40 is giving us 60 degrees. This angle here is 65 degrees, and the question says we are looking for this angle here, PSQ, which is this angle here that we are looking for. And the sum of angles in a triangle is 180 degrees. Therefore, 65 degrees plus 60 degrees plus the angle we are looking for, PSQ, equal to 180 degrees. Reason, sum of angles of a triangle. So if I add this and this, I will get 125 degrees plus angle PSQ, which is 180 degrees. So to get angle PSQ, I will move this to the other side and it turns to negative. So PSQ will give us 180 degrees minus 125 degrees. And once I do that, you will see that my PSQ will give me 55 degrees as the answer. Don't fail to visit www.metricEdu.com to apply and get the reward by this Saturday. Thank you so much for viewing, and may God bless you. Remember to subscribe to my YouTube channel, Facebook page, Instagram, TikTok, etc., so that you'll be notified each time a new video comes up. Remember, I upload daily.